Alright, construction of voltaic cells or galvanic cells, either way. And here are some terms that you should know. And let's see. Draw the galvanic cell described below. Be sure to include all the important features. So let's go through that. A voltaic cell, so same thing, just jumping back and forth, is constructed from a silver ion half cell and a cadmium ions half cell. Silver ion is reduced during the operation of the cell. So what we do, really just, I just draw two containers. You can make them look like beakers if you want. That's what we do in our lab. So we have the container here, and oh, one of the cats wants to be petted. Okay, so no honey. Okay, so we have silver ion, and they say the silver is reduced. So normally you put the thing that's being reduced on the right side. You don't have to, but it's good to get into some sort of procedure so that you don't make any mistakes. So we have silver metal, and you have a solution of silver ion. It's probably silver nitrate, but that was in there. But we can just put silver ion, and that's reduced. So the silver is going to add to the silver metal. Then we have cadmium on this side and cadmium ion. And this is oxidized since this one is reduced. That's why they only have to tell us one of them. So we have cadmium in solution here. Then, so the cadmium, we might as well write down the, it's good to write down this reaction here, this half cell reaction. So on this side, this is what's happening. The cadmium is coming off and into solution as the ion, and the electrons are leaving. They're going through a circuit, through a wire, in this direction. So you should draw that as well. Because you have this added amount of electrons here, because the positive charges are leaving, then this is negative here, and so this side would be positive. That's what's drawing the electrons over. This positive charge is adding here. The electrons are connecting with this the silver ion, creating silver. And then, so on this side, it's silver ion plus one electron goes to silver solid. So you should have the phases in here. And I only put one electron because we just want to show the string, which way the electrons go. Not that the stoichiometric amounts. Because you can see that they're going to be different here. And when we balance the whole thing, which we're going to do, we're going to have to change the number here, but we just want the half reactions here. And then you also put in above, or connecting the two, the salt bridge. And you can just point an arrow at it. Usually it's potassium chloride or potassium nitrate. And what this allows to happen is as the cadmium is coming off in the solution, we're losing electrons, so we need the ions, the negative ions, to come out here, positive ions to come out here to complete the circuit. You don't really have to draw that, but just show that the salt bridge is maintaining the balance of charge. So it looks like we have everything that we need here for and then the last thing would be to complete the reaction, give the overall cell reaction. And 2 silver. And that would be that. I think that's all we have. Let me double check. Yeah. So let's do another one. Voltaic cell constructed from copper, copper 2, and magnesium, magnesium ion. So it's saying that we have, what this means, it's copper metal, and then the copper ion in one half cell, magnesium and magnesium ion in the other half cell. Copper is reduced. So do it again here. We have just a container. It can be a beaker. You have your solutions. Copper is reduced, so you put it on the right. And if you feel like, well, I should be able to put it where I want, sure, go ahead. But what happens is if you just keep and there's no reason that physically, there's no physical necessity to have it on the right, because if this was a real lab, we could just, if we walked around to the other side and looked at it, we'd see it was on the left. But the reason you want to always do it this way is so that you don't get confused. Say on the exam, when you're trying to write these up, you might make a mistake, or there's more chance of making a mistake. So you have your salt bridge here to complete the circuit. Didn't leave a lot of room for the wire here that's going to go across, but the electrons are always going to go in this direction, and another reason to put the reduction on the right, because then the electrons will always be going off to the right. You don't have to think about it. This side is going to be negatively charged, this is positively charged, and the salt bridge will keep the charge in balance. And there's always going to be a slight imbalance, that's the potential, but it keeps it from the charge from building up. And if the charge on were to build up so much on one side or the other, the reaction would stop. If this side became, as we lost more and more of the species, it became too positive here, the electrons wouldn't be allowed to leave because they'd be attracted to all this positive charge. And this side would get so negative that the electrons wouldn't want to head towards it. They'd be forced back. So the salt bridge completes the circuit, allows the charges to try to keep the whole system neutral. And that would be, so no changing of coefficients here, everything's fine. So these are the half cell reactions. This is the overall cell reaction. Oh, that is one thing I should mention here. So this would be the oxidation. That is very important. Yes, we need to have that in there. This is the reduction. I've been kind of saying it, but this would be the cathode then. So yeah, that needs to be pointed out. Thought there was something that seemed a little empty there. So we mentioned this is a salt bridge. This is the anode. This metal is the cathode. This is the oxidation side and the reduction. Yeah, so we need that in there. So we label this as the cathode. The anode, they're both electrodes, but the anode, that's where the oxidation takes place. Both vowels, oxidation and anode, begin with vowels, so that's how I remember it. Then we have the reduction, which is on the right. Another thing to remember. So all of that needs to be in there. Sorry about that, but yeah, just looking at this gives you the flow of the electrons, shows both half cells, show the anode and the cathode, label them, show the ions in solution. The charge, the general charge on each of the electrodes, half cell reactions, and then label each of the half cells, and then or what type of half cell reaction, and then the overall reaction. And that should do it.